All right, welcome back to Digital Drafting and Design. This is Section 2, Lecture 6, Site Surveys. So we have some changes with some of our section objectives since Lecture 5. I want to go ahead and point those out. So Lecture 6 is now, it's still going to cover site surveys, but we've added that report that you have already seen on Canvas. For Lecture 7, we're going to have the guest lecture going over subdivision and ALTA surveys, and there will not be an assignment along with Lecture 7. Moving forward with that, everything will be the same. We'll talk about as-builts for Lecture 8, and Lecture 9 is going to cover ArcGIS Pro for surveying, and both of those you'll have assignments related to your final project, which will have their own lecture videos. So let's go ahead and get forward. What is a site survey? So a site survey is a type of land survey focused on collecting data from a project site for pre-planning of engineering projects. It's going to have several different parts to it, and that's because this is going to be a much more extensive survey than what we're traditionally going to see. A lot of our surveys are more, singular or individual objective oriented, as to where a site survey is going to cover a plethora of different things. It's really looking at like a full project. Some of those parts are going to be, at least from general terms, going to be a planning phase, a site analysis, a boundary and control survey, a phase of identification of existing infrastructures, and then finally a survey report. So let's talk about each of those a little bit more. So first off, we have our planning phase. That's going to be the beginning of any site survey, and it's going to feel very similar to other surveys that we've done in the past. Before we go out in the field, we're going to be trying to identify different environmental hazards that we may be exposed to in the field, different obstacles that we're going to have, whether that's going to be physical infrastructure, or if there are going to be, trespassing restrictions on adjoiners, things like that. We're going to try to find out as much as we can before we get out there, and then identify what type of equipment is going to be best suited for the surveys that we have to conduct as part of the site survey. And that's going to be dependent on things, are we looking at heavily wooded areas? Are we looking at lots of topography? Things like that. Can we use drones? Can we use LiDAR scanning? Can we even use GPS? Or is it too covered that we're going to have to go traditional? Things like that. We're going to look at all that information ahead of going out. A lot of that's going to be decided, using modern technology, Google Earth, Google Maps, whatever it is that you're using to kind of review that satellite imagery and see what is it that we see at this site. Is there water? Is there, again, environmental hazard, all that. Don't need to rehash it. But just trying to figure out as much as we can before we go out there. And then where we might differ a little bit from our traditional surveys is we're going to have to look at the different types of analysis and observations that we may have to take while we're in the field. Is our project going to call for soil tests while we're out there? Are there going to be environmental and regulatory factors that impact this survey? If you're doing a site survey as far as like a wildlife protection survey, or if it's some type of environmental survey, there's a lot of different factors that you're going to have to take into account for to make sure that you're not disturbing things that aren't supposed to be disturbed, or you're capturing the right information that it is that they're looking for. They're going to be, if we have geological surveys, do you need to bring like rock collection tools? Are you going to have to bring samples back, things like that? Tree surveys, all of that. And then zoning maps. So if it's a more development type project, they're trying to identify, what's the usable space here before an investor potentially purchases it for development. There can be a lot of stuff that goes into that, looking at local regulations. What's the process to have things changed? You may be tasked with some of that work, that legwork, collecting all this information, these attributes related to this property. And again, this is where we really differ, because we go from just traditional land surveying to all of a sudden we're looking at survey work, we're looking at engineering work, environmental work, and it's not necessarily just going to be you that's doing all of this by yourself. This is probably going to be a team of people, so you will have civil engineers or environmental engineers along with you, the survey engineer, bringing all of this information together, but you typically work as a team and support each other, so you might have to cross-train and learn a lot of this information. But after our planning phase, we move on to our site analysis. So this will be when you actually set foot on the project site. You're finally on the ground. This is when you're going to start collecting things like your topo data, soil samples that you might have to collect, identifying watersheds across the area. There's a lot of work to make sure that we mitigate flood impacts these days, and we protect as much groundwater supply and stormwater runoff as possible. So looking at watersheds could become a major factor for your surveys, and then again doing vegetation surveys. So whether again you have to do tree identification surveys, you have to do wetland vegetation identification, and potentially riparian boundaries, collecting all that information, that all starts coming into play here. And then during this phase, you as the surveyor, you're also going to start scoping out, where am I going to establish my traverse network? Am I going to have primary control networks and intermediate control networks? Where am I going to have my control points set up throughout my site? And this isn't just your control points for your traverse, but for other parts of your project as well. Is this a construction project? Do I need to set up certain monumentation to leave back to continue to reference? If you're doing a wetland study, if that's the overarching project here, you're going to have to establish control that's going to survive that environment and last long term. Where's going to be the best point to establish that? Really, that vertical control is most likely what you're going to be looking at that point. And you, the surveyor, start thinking about all that when you see the site in person during your site analysis. Again, any factor that could potentially impact your construction or project goals are going to be captured at this time. And that's going to come back later as well during the existing infrastructure phases. But right now we might be looking at more of our physical or our geographical features that might be impacting us. Collect all that information. Oh no, we've identified a known endangered bird species that's going to impact our ability to continue with the project. And it's like, then that sounds ridiculous, but that's a serious thing a lot of people do. There have been a lot of projects, specifically in the Austin, Texas area, that have been shut down to protect certain endangered species of birds in that area, because the rapid population expansion has just decimated their environment. So you may be the guy that has to point that out, moving forward in some of your projects. And again, we're gonna kind of assume at this point that GNSS or GPS equipment is going to be available for use, through your employer. Otherwise, a site analysis phase, you wouldn't really be able to do this until after your boundary and control phase. Obviously, you can't do side shots with the total station if you haven't done your boundary and control already. But that does lead directly into our next point, which is our boundary and control survey. So this is where you're actually going to run your traverse and establish your discrete boundaries that are going to be relevant to your project. I know you all recall what discrete boundaries are, what discrete data is. That's things that they have limitations. You can identify where it starts and where it ends, as compared to like contiguous information. Like the topo data you're collecting is contiguous. It runs off the edges of your page. There is no start and end to it technically. That data goes forever. But here we're focusing on discrete boundaries, and this is where I was saying before, we have our primary and our intermediate controls, and those are what we're going to have to look at this time. So your boundary survey, again, you're recovering things like your legal boundary, your easements, potential encroachments that may be on this project site. There can potentially be a lot of courthouse research involved with this phase. Typically when you see something like boundary and control survey, you're thinking field work. I'm going out in the field and I'm doing all this work. I'm collecting these points in the ground, but in reality, you have to know what you're looking for ahead of time. You have to capture maybe existing surveys for the legal boundaries. That is a retracement. at that point. You need to know about your adjoiners and restrictions and right-of-ways and easements and things like that. Potential agreements between past landowners to where maybe an encroachment is not technically an encroachment. It's a handshake deal. And in Texas, the handshake rules apply. That is a legal binding agreement. So you have to kind of make sure you investigate all of that information at this time. And again, going forward, the control survey, or your traverse, that's when you're establishing your points of reference for your horizontal and vertical control throughout your project. So the control survey may be more complex than just your traditional boundary survey because intermediate networks may be necessary. And this really gets into more construction surveying at this point, those intermediate networks. Because imagine we're having to build a road through this property, and the site survey you're doing is capturing all these boundaries, these legal boundaries for these parcels that are going to go through, identifying the new right-of-way or the new easements, and then setting out all of your control for the surveyors that come after you to do the construction surveys. In order to mark out, all of those vertical changes along the project. So those networks are things that you're going to establish, and then almost inevitably a grader or someone is going to take out a point, and your job is going to be to come out and reestablish it. And that's where your primary network and your intermediate network are going to tie in together. All right, and the next phase is going to be your identification of existing infrastructure. So the final phase of a site survey's fieldwork is the identification of existing infrastructure. This is where you're actually looking at what all have we put in the ground, what already exists on the ground out here that's man-made. We're looking at gas lines, data cables, drainage systems, electrical wires, buildings, roads, walls, even rubble and debris. If you've got old dump sites, anything like that is going to tie into your project, and you have to identify all of that information to the best of your ability while you're out there. And it's during this phase, usually you would utilize utility companies in order to mark any existing or active underground utilities. Here in the state of Texas, we have Texas 811, call before you dig. That's not just for homeowners before they do a backyard project. That's for construction companies. That's for us, for surveyors. That all should be marked, and we would be able to follow over that and capture all of their markings to put that on our maps for analysis. Again, if you're doing maybe it's gas lines or pipelines, if you do pipeline surveys, you go out and you utilize tools. It's kind of this three-pronged fork thing. You go and you're into the ground, identifying and tracing, out where that pipe exists and shooting all those shots. It's a lot of work. Pipeline surveying is a lot of work. It's hot, it's clear cut, so you're directly in the sun, and it goes for miles. If you haven't done one, you got to do it at least one time, but builds character, as they say. But no, so that's the kind of information that you need to start thinking about, because the importance of making sure we have underground utilities or overhead risks are vital, because nothing is going to impact your project like a safety incident. You hit a high pressure gas line, and someone literally can die. And that's the kind of thing where if we were responsible for capturing that information, if it was in the expected purview of our job, and we miss that, or we mark it incorrectly, you're potentially getting someone killed there. And we have to be very sure that the work that we do, that the data that we put forward is as full and complete as it is reasonably to have. We'll talk a little bit about that reasonably to have a little bit later as part of our survey report, because we're going to take a deep dive into that. But again, do not devalue the importance of identifying existing infrastructure. It's not just, okay, hey, there's a house here, let's shoot the sides. Oh, there's an old slab, but what is underground? Why aren't we seeing utilities? Where are right-of-ways and easements, areas that we need to be extensively careful? Obviously, things that impact project deadlines are not good, but things that put workers at unnecessary in unnecessary danger, that's unacceptable. So we need to do our job to, again, protect the public at large by identifying any underground utilities that we can. And then lastly, we have our survey report. So finally, the surveyor, you create a detailed report of the on-site conditions and data. You're going to create a report that includes, detailed maps of the site's boundaries, all of its control points, existing infrastructure. It's also going to present the site's topography, things like soil composition and environmental conditions as required by the project. And again, when it's done, this is something that's going to go into the hands of architects, engineers, contractors, and utilized for the remainder of that project. So throughout that project, people are going to be referencing your work. When I talked about the intermediate control networks during the boundary and control phase, establishing those, for potential alignments or for roadway projects, those points that you set, that horizontal and vertical control that you set, is going to be used and vitally used throughout the project for where new construction gets put. And it sounds ridiculous to this idea of, building a road or a house, in the wrong location, but it unfortunately does happen. And lots of times we're talking, tens to hundreds of millions of dollars of potential damages or losses because either someone failed to get something surveyed or it was surveyed poorly and created an error. And we just need to make sure that we do our job to make sure we provide clear and accurate information, plats, and notes, and reports to ensure that things get done correctly in the correct locations and the right spots are dug into. But I want to go into a little bit more detail on our survey report and what that would look like, because this is something that you'll likely be creating in your future surveying and field camp courses. So let's take a look at that. First and foremost, let's talk about what are the parts of a survey report. And I think there are 8 main parts to a survey report. Those are broken down as your title, your purpose, your contents, your data, your survey accuracy, your survey execution, your conclusions, and your recapitulation or your recap. Those are your 8 primary parts, and let's go into detail on each of these. So starting off with our title. So as an example title, you could say this report covers the surveys of the Joe Blow 22.57 acre tract, a part of the John Henry Brown Survey Abstract 123, Burnett County, Texas. So immediately we know that the survey was authorized by, Mr. Joe Blow of Burnett, Texas. There's a date associated with it right there, July 1st, 1974. And then, above that, you have the name of your client, you'll have the acreage, you have the location of the property in question. And your survey may cover several tracts. If so, you would name each of those. So there's a lot of information right there in that title that we're going to be able to capture. And it's important to have, even if it's lengthy, a clear and detailed title to make sure that the land you're talking about is explicitly defined there. A title like, GISC 1336, GISC Project 1 report, that's not necessarily an appropriate title. It doesn't tell you that much about it. It's like, hey, I know who it was authorized by, GISC 13.6, I know who did it, GISC, and then it was Project 1, but like, where is it? What's the space of it? And we've seen that in some of the legal descriptions that we looked at previously in lecture and lab 5. So think about what you saw on some of those plats and those field notes, how much information was associated with them. And then after our title, we're going to have our purpose. So the purpose is going to be a kind of clear and concise way to cite the reason for your survey. An example of that would be the purpose of this survey is to determine the location of all corners, reestablish any missing corners, boundaries, conflicts, if any location of structures, easements, and acreage. So it's simple, it's clear, it's direct. What was my job on this survey? Identify these things: corners, boundaries, structures, easements, and then provide acreage. Clear and simple. A lot of that information may be also tied into your title, but now your purpose expands on that just a little bit more. And this is important. This is what you're hired to do. You may have done additional work, things like that, but that's not necessarily the purpose of this job. So that's other information is left out of your purpose and is included later on in the report. All right. So after we've defined our purpose, we get to spell out, what are the contents of our report. So a quick example of that, you can say, hey, this report contains a report, an ownership map, a working sketch, an aerial photo, and a survey map. So what you're looking at there with all these things, this is the actual, and this is your table of contents. These are the things included within my report. Now, mostly what we're talking about here is just number one here, the report itself. But at the end of that report, that's where you'll see those additional pieces of information, those products essentially that were created throughout this job. Then we have data, and in my opinion, this is going to be one of the largest sections of your report, because you're going to be talking about everything that was collected, everything you gathered, not just your information on the ground, not just these tables of data, of point information, your curve tables, all of this. We're going to be talking about, hey, what's all the courthouse information you collected? What's the stuff you may have collected from the city? What's a record of what was collected from adjoining landowners? All of this information is going to get tied into it. And you're going to have that quick recap at the top of your data before you go into each one. And that might look something like this. The data has been gathered from the following on the land in question and adjacent tracts. I have my courthouse deed records, I have court records, I have survey records and abstracts and the following. We include descriptions from the general land office, following records or searched, copies of original field notes. Are they canceled field notes that were obtained from past landowners or surveyors that have done previous retracements? Any roll sketch files, letter files that we searched through, old county maps that are examined, land office working sketches that you consulted, your own working sketches that you created, district survey records, if they're available, and if you can't find anything, you're going to put what you didn't find that you looked for as well. And then lastly, anything like aerial photos that were obtained for specific areas of interest. So all of that information is going to come in here. First, you're going to talk about it, and then you're going to show all of that, include it, or put it in there and have a reference to your appendix where it may be located. But lots of information in your data. The more you find, the better. And of course, there are limitations, and again, we'll talk about that a little bit more. But keep that in mind. Anything that you can or that you wanted and were unable to find should be included here. Then our survey accuracy. I know we talked about this in previous lectures. You need to make sure that you're being clear about what are the accuracy, the limitations, measurement limitations of the equipment that you used, of the data that you used, and how that compares to your equipment. So if they were running things rods or chains or whatever previously, you got to talk about what limitations they may have had, and then when you did your retracement or further did your survey, what's the accuracy of your equipment? So, and then how you improved the accuracy of your measurements. So, talk about, the explicit equipment that you did use, they did a double center traverse in this example. Did you do this? How did you correct it, or do adjustments to your data? If you had equipment, when's the last time it was calibrated, or if anything was in good repair or potentially got damaged on site, it might be a time to do it. What order of closure were you looking for with any of your aerial imagery in your GNSS data collection? What type of angular errors did you limit any of your individual or overall measurements to? And again, just what are the actual limitations of our equipment? Because they do have limitations, and those should be stated here. Just because the computer can point out 20 decimal places doesn't mean we measured that accurately. And again, this is another time where if weather conditions potentially impacted your survey at any point, those would be listed here, and which equipment and sections may have been impacted at that time. Because it's important to document where something may have been adversely impacted. Just like in our field notes, we'd include it in our report as well. Then we talk about the survey execution itself. So what did you find on the ground? How many original corners were there? If one corner was unrecoverable, how did you, what methodology did you use to identify or remark that point on the ground? Did you use two existing calls to it on either end of it and call back to it? Was it just a simple COGO or an intersection, or did you find maybe not original monumentation, but another pin that was set and referenced as a replacement to the original monumentation? All of that kind of information needs to be included. If you set your new ones, what did you use to set it? What type of material? What type of cap? What's the label or the marker on the cap? If you set a lathe with certain marked tape on it, identify all of that at this time. Just to kind of keep all of that in mind. If you found things that were in the ground, maybe potentially called for and other stuff, if you rejected it, why? If you identified mathematical errors or retracement errors on previous retracements, and then you found where they set their points, why did you reject it? If you identify a pin cushion, which piece of monumentation did you use, and why did you reject the other ones? Those are all going to be relevant here at this point. What was your thinking as you were going through and doing this survey? Found encroachments, where were they? How large were they? Why do you think they're an encroachment? Can you identify potential past agreements or easements that would have allowed an encroachment? All of this information is going to be relevant. I said before, how handshake agreements are legally binding in the state of Texas, but sometimes someone allows an encroachment on their property, but they do not actually cede ownership of that property. They say, hey, as long as I'm here, I don't mind that the fence is a little off, it's already up, let's not move it. Oh, you've already built a shed, that's fine, I don't care. While I live here, it can be there, but I'm not giving you my property. Things like that are relevant, because technically, if that's the agreement and you can find evidence of that agreement, the new landowner does not necessarily have to honor that if it's not included in the sale or the purchase of the property. So there's things to take into consideration there. And just for anyone that might be thinking about adverse possession, squatter rights, tenant rights are something that are highly complicated in the state of Texas. Even right now, as we record this lecture, April of 2025, the state is still working to expand tenant rights, to close as many avenues to adverse possession as possible. So those are things that we need to take into consideration right now. When you see here, we're talking about estimate the age of an encroachment. All of that's going to be relevant and important at this time. So, you need to, if you're in a, neighborhood or an HOA-based area, what are their rules about encroachments? Do they have documentation of it? Any individuals that you contact that provide you information or consultation on that encroachment. All of that information you're going to want to include here as well. And then again, of course, like I said before, with the existing infrastructure, you need to identify things like pipelines, high lines, telephone lines, power lines, anything utility-wise, anything that is a potential hazard or obstacle for the project moving forward needs to be included here. Whether you think it may be an obstacle or not is irrelevant. If it could be in any form, if it exists, it's there. Put it in your report, mark it in the survey execution. This is everything you found. You saw some data on it before. Here, I'm telling you again, I found these things. This is what they were. This is the reference documentation that I might have had in my data as well that set those easements or those right-of-ways. All of this gets taken into consideration right here. It's what you did, how you did it, who you talked to, all of that. Who, what, when, where, why. Right here is your survey execution. And then you have your conclusion. So again, you found encroachments. Where were they? How much of an encroachments were they? If your investigation indicates it has been in place for over 10 years, your report's going to need to show that, because that's where adverse condition technically starts coming into play. Investors or potential buyers or developers need to know about this information, because there is a possibility of loss and limitation to their site. If you have acreage that's in conflict, it has clear difference in any bearings and distances from previous records that you found, especially the original survey. All of that information is going to need to be included in that conclusion. Kind of put together all those last little pieces and kind of identify, is the property in good order or not? And then simply your recap, your recapitulation. So boil it down. Summarization of everything in your entire report. Important things here, and this is where I talked to about to the best of your ability or any potential limitation to your ability to research, do any type of research that you may have found to be necessary. If your client is limiting you, whether it's just because they don't want to look into certain things and they've explicitly told you that, if you have cost-related limitations to what you're doing, if there were time limitations, anything that impacted your ability that you think potentially could be important to consider going forward, you're going to put that here. So whether it's records or additional surveys or types of data collection, different methodologies used, if you used a inferior method of data collection, include that information here in order to capture all of the potentially relevant information. And this section isn't necessarily meant to be your giant disclaimer for everything that you wish you could have done that you didn't do in order to protect yourself. But that is a bit of the ideal of the recap. So again, everything that you did do, and especially everything that you didn't do, why you didn't do it, how it could have been done. If it was something that was explicitly limited by your employer or your client, or if it was just a time or environmental thing or an access thing, that information is all going to go into the recapitulation. And you'll, with time and experience, you'll kind of identify how much of that information you need to put here. Sometimes less is more. If you're doing just a neighborhood survey and they brought in new earth to raise and build on like they do most places these days, but you didn't get to do certain types of soil analysis, or you didn't get to do aerial surveys or watershed surveys or anything like that. If you just did elevation certs and lot and block surveys, that's fine. That's what you were hired for. You don't need to put all of the things that you could have done. It's only the ones that you explicitly feel like needed to have been done. And again, that's something that you'll kind of grow into as you gain more and more experience as a surveyor, how much of that information you need to put here. Because when a survey or a project doesn't call for certain things and you try to put that in here, it's going to it's going to make you look more like a novice and less experienced. And it might be frustrating for clients to see all of that information there, because it could become a hindrance for them further down in this project. Because like we said before, this report, these maps that you produce, they're going into the hands of everybody else involved with this project after you submit it. And if you have giant disclaimers saying all these things weren't done and you weren't able to look at any of these things, someone somewhere that maybe doesn't understand the need or necessity of those things might say, hey, this is in here and we were told we needed to do it. Why didn't we do it? That's going to look bad on you, and that's going to hurt your reputation or your rapport kind of with that potential client, who in this case, might be a large developer in an area, or could be a local jurisdiction, because you're putting information that's not technically relevant to this project in there and saying it wasn't done. And it's like, well, of course it wasn't done. It wasn't part of this project, so don't put it in there. Again, I'm rambling a little bit at this point, but that's just kind of what it boils down to. So with that kind of wraps up lecture 6. Just going back up, we talked about, again, site surveys as a whole and all those different phases of site surveying. So our planning phases, where we're gathering information in office before we hit the field on what we're getting ourselves into. We have our site analysis, where we're really starting to identify hazards that we might be facing throughout our project, as well as different types of data collection that's going to be necessary. Is this everything that I myself as the surveyor am able to do, or am I going to need to bring out additional types of engineers or environmental scientists with me? Our boundary and control survey, and that's the real thing that we're here for. That the first and foremost is we establish that horizontal and vertical control and identify the legal boundaries of our site. That's the boundary and control survey phase. Our identification of existing infrastructure, again, it's a vital phase as far as worker safety and meeting project deadlines are concerned, identifying everything that's already out there quickly and concisely to the best of our ability. And then lastly, that survey report. So it kind of puts everything that we've done together so far into that report to submit for the use of everyone else on this project. All right, so that's it for lecture 6. Thank y'all.